Hi, I'm Eric Hanusa with Rocky Mountain High School. I'm working with the University of Wyoming and the National Science Foundation to work on 3D printing optimization. This is a computer science-based program that we're working on to get data to make sure that the estimated print times are close to the actual print times. To do this, we're going to use our MakerBot 3D printer, select a few objects, and print them based on various scales to try to chart out a baseline. To do this, we selected two objects. One is an XYZ cube, and the other one is an astronaut-shaped character called filament. Here's an example of what those objects look like. I'm now going to show you how we found those objects. We're going to go to a website called Thingiverse on the internet. It also has a MakerBot software where you can find your files to have control types. And then I'll show you how to download those and access those. All right, so here is the website Thingiverse. It's also sponsored by MakerBot. The whole point of Thingiverse is to be an open source format where people can go through, put their ideas on the internet and have people use them, modify them, or try out practical applications. So kind of an inspiring way for the home hobbyists, for the open source, as well as engineers to design and develop things with 3D printing, sometimes lasering and other formats. So I want to type in on here filament, just to show you how this works. This is filament. I'm going to search filament. Here's the astronaut that we chose to design. All we have to do is, now we've gone to this model. To keep a control model, I can go to download the files here. So there's one thing file. I simply click on it. And it shows down here I can download that. So that is our control object. The next thing I can do is just simply drag and drop this to my desktop. From there, I'll show you what our next step is. The other file that we found was also on Thingiverse. It was called the XYZ calibration cube. So I went to the model there. I downloaded that as well. Take that file from here and just add that to my desktop. Okay. The other thing is, based on our 3D printers, we have a 3D printing source called MakerBot. That is what we will use to, what's called, slice the 3D print. So all I need to do is take my astronaut, drag and drop it onto my 3D print workspace. So that's inserting my file. From there, I've got different options. This is my build platform, so I can move them around, do different things I want to do. But one thing that we had to make sure is we controlled our settings. So we went onto our print settings. We have all these different things that we can adjust, and based on our project, we had them consistent between the two 3D printers. So we were able to get consistent results based on the slicing software. So when we downloaded that file from MakerBot, or Thingiverse I should say, this is usually what's called an STL file. What that does is take the solid object here, which is in our 3D CAD software, where we could modify it if we wanted to. In this case, we don't need to make any modifications to it because we want it to be a controlled object. So we're going to leave it as it is, but that STL file is going to be important. We want to make sure when we go to 3D print things that we have an STL file so that format is consistent. So by having that file format, we're able to drag and drop it here. Now, if all those things are accurate, in this case, I have a Z18 3D printer. Bryce and Chugwater has the MakerBot Sketch. So once I'm done, if I've modified this to what I wanted everything to be at, if I'm happy with it, I can simply hit export. What that's going to do is I'm going to name it XYZ. As you can see, some of the other files I have. I'm just going to put 100% and go from there, and I save it. Now it's estimating the print time. So it's taking this three-dimensional object here that we have, and it's slicing it into little layers and making what's called a G-code. And that G-code is going to allow this 3D printer to build each layer of this object from the bottom to the top. Now this estimation is going to be important. We're documenting what the estimated time is it's going to take to print versus the actual print time. So let's see what it generates. All right, at this point it says it's going to take an approximate 3 hours and 50 minutes to print this object. And it's going to tell us it takes approximately 40 grams of PLA filament. And those are all presets that we put into our control. One other thing that we did is we decided to scale this to see if the estimated print times are going to be close to the actual print times. So once I'm good with that, I can take that file that I exported and save it into that folder. And then I can send it to the printer. Here's our MakerBot Z18 at Rocky Mountain High School. It's kind of hard to see the 3D printing, so I've put it on the floor so you can get a better viewpoint of it. I'm going to try to move closer here so you can kind of see what's going on. So we're printing, in this case, one of those filaments, little astronaut character. It's zipping back and forth, printing layer upon layer. We wanted to represent our data sheets based on our current hypothesis. We have a MakerBot print times generated on slicer versus actual times. Units are in durations of hours, minutes, and seconds, and milliseconds. What we did in the first model object is we took the filament, we had the maximum print time based on time estimates of 100%, and our controlled settings, it told us that it was going to take 4 hours and 55 minutes based on our previous controlled settings. We then wanted to make it based on print times shorter than that. So in this case, we scaled the model down and we went from 70%, 50, 40, 30 to 20. For a better controlled data, we printed each one of those sizes or scales 3 different times. And then based on our data, we were able to chart the estimated print times and come up with a formula calculation here. We did the same thing for the XYZ cube. We have our filament for Bryce at Chugwater, and then we have our XYZ data cube here. And this was once again based on build times or print times is how we chose our model sizes. In this case, we scaled it up to make it larger. We went from the 100% to 120, 130, 140, 50, 70, and 200. And that gave us better print times. Using that data, we were able to take the 2 different 3D printers at the 2 different sites, and we aggregated them together. We have the filament at 20%, so then we have 6 data points based on that, 30%, 6 data points, and so forth. We're able to get a better combined data sheet for each model that we printed, and then we were able to chart this, and it looks like based on the longer the print time, the more accurate the data is for the estimated to actual print times. If you find our 3D printing model was something you're interested or want to try a slightly different variation, here's our paper that we've generated that will be available. That'll give you a little bit of our abstract here of our main goals, our 3D printing optimization with computer science, kind of the background of 3D printing, how the slicers and G-codes work with some algorithms, information and data there. And then all of our data will be found in the bottom. It is a pretty short read, even though there are quite a few charts and graphs, has our controls and such. Anything you might find interesting that if you wanted to try a similar hypothesis or to grow this, give you some interesting points to read. We hope you find our data and our research exciting as we worked on our 3D print optimization. Hopefully you can take this and use it in your everyday life. Thanks.